Hello everyone. So in this video, on this slide, I have 4 different Lewis dot structures that are shown. I have 4 different Lewis dot structures that are shown. And I want you to be able to identify or say something about the number of electron groups, the number of bonded groups, and the number of lone pairs of electrons on the central atom. Now later in the chapter, you're going to learn how to actually draw these 4 Lewis dot structures using rules that I will give you. But right now, I just want you to focus on being able to say something or determine numbers of electron groups bonded and lone pairs on the central atom. Because knowing that's going to be important later on in determining overall shape or geometry of the molecule. And when we do these kinds of problems, we really only care about number of atoms bonded and number of lone pairs of electrons on the central atom, And for molecules in this course, there's going to be a defined center that you'll either be able to see from the structure or that I will tell you which atom is the center atom. Let's start with this first one, NF3, nitrogen trifluoride. If I asked you how many electron groups were on the central atom being nitrogen. So number of electron groups include not only bonded atoms, which in this case there are 3 fluorines, they also include number of lone pairs. So aside from the 3 bonded fluorine atoms, there is 1 lone pair of electrons on that central atom, on the nitrogen. So there are a total of 4 electron groups on the central atom, 3 of which are bonded, the fluorines, 1 of which is a lone pair of electrons. Okay. So we can do something similar for this next molecule, CCl4, carbon tetrachloride. You can see this from the central atom, that is carbon. I have 1, 2, 3, 4, a total of 4 bonded groups. I don't see any lone pairs on the central atom. I see a lot of lone pairs on the chlorines, but I care about lone pairs on the central atom. So since there are no lone pairs on the central atom, all of the atoms or all of the electrons are participating in bonded situations, we would say there's a total of 4 electron groups, all of which are bonded, and there are no lone pairs on the central atom. Okay. So when counting bonded electron groups, for Lewis dot structure theory and VSEPR, that we'll talk about later, it doesn't matter if you have single bonds, like between this N and Cl, or if you have double bonds between like the N and the O here. Regardless if you have a single, double, or even triple bond, that bond is still counted as 1. So when looking at this structure with nitrogen as the central atom, I would say I have 1, 2 bonded groups and 1 lone pair of electrons on that central atom, to give a total of 3 electron groups on the central atom, 2 of which are bonded, 1 of which is a lone pair. So then finally for CS2, with respect to the central atom, and we always care about the electron groups around the central atom in these problems, I have 1, 2 bonded groups. So I have 2 bonded groups, no lone pairs. So I have a total of 2 electron groups, both of which are bonded, and no lone pairs. Okay. So you should feel comfortable being able to determine total electron groups, bonded groups, and lone pairs on the central atom given a Lewis dot structure.